Okay, let's dive right into this because we have a lot of ground to cover today. Welcome to a very special explainer where we are going to completely, and I mean completely, transform the way you approach your Cambridge computer science exams. I want you to think of yourself as a sculptor. Right now, your knowledge of topics like binary and decimary number systems, it's basically like a massive, raw block of marble. It's incredibly heavy, it is absolutely full of potential, but it's completely undefined. You've got all the facts, but they aren't shaped yet. So today, we're going to learn exactly how to pick up the chisel, chip away the irrelevant parts, and carve that raw binary knowledge into top-tier, absolute masterpiece exam answers. Whether you are sitting for the 0478, the 0417, the 2210, or the 9618 syllabuses, the strategy we are unpacking today is your definitive blueprint for success. Look, you've already put in the grueling hard work studying the theory, memorizing the concepts. Now let's master the exact step-by-step method to actually put those marks on the page and get the grade you deserve. So here is our blueprint for the sculpting method today. We'll start with the digital problem, move into the 3 layers of knowledge, figure out escaping generic answers, tackle sequencing the process, and wrap it all up with the 4-question check.
Let's kick things off with Section 1, the digital problem, or as I like to call it, the raw block of ideas.
Now, you might be wondering, and it's a completely valid question, why do students who know exactly what binary is still lose marks? Binary and denary aren't just isolated vocabulary lists that you blindly memorize, but it's a frustrating reality for so many students. You know how to convert base 2 to base 10 perfectly, you know the math, but you get your paper back and the marks just aren't there. Why? The answer is that surface features distract from the deeper analytical process. You see a question about a microprocessor, you spot the word binary in the prompt, and your brain just immediately goes into panic mode and starts dumping every single fact you know about ones and zeros onto the page without actually answering the specific question the examiner asked.
To really understand this, let's look at 2 typical student approaches to a past paper. First, we have Alex. Alex sees a question about data representation and absolutely overloads the page with raw facts. Alex writes, binary is base 2, it uses 1 and 0, denary is base 10, computers use logic gates. Okay, let's pause. Everything Alex wrote is technically true. It's a massive block of uncarved stone. But Alex scores absolute 0 for application. Why? Because Alex didn't analyze anything. It's just a brain dump. Then, on the other hand, there's Sam. Sam is a sprinter. Sam rushes the command words. The prompt clearly asks the student to explain how, but Sam just writes, it uses binary to make it fast and readable by the computer. Sam gives this incredibly surface-level description, completely missing the actual mechanism of how the system works. Both of these approaches, throwing a raw block of facts like Alex or rushing past the critical command words like Sam, lead to completely avoidable mark losses, and we are going to fix that today.
I want you to burn this quote into your memory. Description tells what the device, process, or method is. Explanation tells how it works and why it matters. Distinguishing between these 2 concepts is where your computer science reasoning goes from average to incredibly strong. Examiners usually expect both, especially for those higher mark questions. If you only describe what binary is, your answer sounds safe, sure, but it is way too shallow to get the points. Conversely, if you jump straight into explaining how a system works without clearly naming and describing the core concept first, your response can sound confused and disjointed. You have to balance the what with the how and the why.
Which brings us to Section 2, 3 layers of knowledge. This is where we start carving the concept.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so to truly master a topic like binary and denary, you cannot just stay on the surface. You must intentionally move through 3 distinct layers of knowledge. First, there's the simple explanation. This uses everyday language so you conceptually grasp it. For example, computers only understand on and off. Great, that's layer 1. Second is the technical explanation. This is where you bring in the correct, rigorous subject vocabulary. So on and off becomes discrete voltage levels and logic circuits. Much better. But then we have the third and most crucial layer, the exam explanation. This is where that technical idea is specifically shaped into a response that scores marks under intense time pressure, totally tailored to the specific scenario given in the prompt. Students so often think they know a topic inside out until they actually try to express it in that rigorous third layer. You have to practice all 3.
Now, let's look at what I call the computer science exam attack sequence. Think of this as the Peel framework, point, evidence, explanation, link, but specifically supercharged and adapted for Cambridge computer science. Step 1, identify the demand of the question. You have to decode the command words. Is it asking you to describe, explain, compare, or evaluate? Step 2, classify the correct concept. Grab the right tool from your mental toolkit. Step 3, explain the sequence or structure step by step. Don't skip steps assuming the examiner knows what you mean. Finally, step 4, connect the explanation back to the context. Always check whether the answer needs an advantage, a disadvantage, or a direct comparison based on the scenario. Applying this Peel structure produces crystal clear, highly targeted answers instead of just writing out facts in a totally random order and hoping for the best.
And this brilliantly illustrates why understanding contrasts is absolutely a crucial point in computer science reasoning. Take memory versus storage, or data versus information. The theoretical foundations of binary systems often depend entirely on these specific distinctions. Training yourself to see these boundaries quickly controls the whole direction of your exam answer. Think about it. If a question specifically asks how binary data is maintained in storage, and your answer starts rambling about RAM, which, as we know, is memory not storage, you lose the marks. Even if your underlying binary math is flawless, you miss the boundary. Clear boundaries make for clear answers. You have to know exactly which concept you are dealing with.
All right, let's move into Section 3, Escaping Generic Answers. This is all about polishing the details of your masterpiece. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to it. Real-world transfer converts memory into usefulness. Please, whatever you do, don't leave your ideas floating in abstraction. Generic responses rarely, and I mean rarely, gain full marks in a Cambridge exam. A genuinely good revision note forces you to apply binary and denary systems to a real situation. You have to stay firmly inside the specific context given by the examiner. If they ask about a factory, talk about the factory.
To bridge that massive gap between textbook abstraction and exam application, you need to map abstract concepts directly to real-world uses. Let's run through some. Take mobile phones. Phones use MAC addresses, which are often represented in hexadecimal. But remember, hex is just a human-friendly representation of underlying binary data. Or take robotics. Robotics use binary for memory dumps and processing real-time sensor readings. What about retail? Imagine you're at a checkout. Retail uses barcode scanners that physically convert light reflection into binary ones and zeros, and then back to Denary to look up a product price in a database. Or banking systems, which use complex binary operations within their encryption algorithms to keep data safe. Connecting familiar, everyday technology to these abstract binary concepts helps you remember the actual reason the concept exists in the first place, not just the textbook label. It makes your answers rich and contextual.
So, as a sculptor, it is vital to know exactly where the chisel tends to slip. These are the most common mistakes I see year after year. First, vague wording, using words like it or things instead of proper terminology. Second, confusion between similar terms, like mixing up MAC addresses and IP addresses when discussing hex and binary routing. Third, missing process steps in a logical sequence. And fourth, this is a massive one, stating advantages without giving reasons. Let me give you an example. If you write, hexadecimal is easier, you get a big fat 0. Easier for who? Easier how? But if you write, hexadecimal is easier for humans to read and debug, reducing transcription errors compared to typing out long binary strings, boom, you get the mark. You justified it. All that vague stuff? That is the excess stone that needs to be chipped away from your answer.
Moving right along to Section 4, Sequencing the Process. It's time for our interactive workshop.
Listen, many computer science topics, especially around data conversion and system operations, are heavily process-based. They require strict logical ordering. So let's test your sequencing skills right now. Imagine you are reading a paragraph describing how a sensor's data is processed by a computer. Somewhere in that sequence, a student jumps forwards and backwards, completely losing the logical flow. I want you to try and spot the flaw. Think about the physical journey data takes from the outside analog world into the digital processor. Where did this hypothetical student mix general theory with the specific context in a way that just breaks the flow?
So, the crucial point is this. The student jumped backwards. They mentioned the microprocessor acting on the data, then suddenly they jumped back to the analog-to-digital converter, and then back out to some general theory about binary. You can't do that. The examiner gets lost. The correct high-scoring sequence explains the mechanism first and the consequence second. It goes like this. 1. The sensor reads the analog data from the environment. 2. The ADC, or analog-to-digital converter, translates it into digital binary. 3. The microprocessor then compares that binary value against a stored Denary threshold. Notice how linear that is? Clarity of sequence directly translates to higher marks.
To achieve that kind of rapid clarity under exam conditions, you need a high-quality revision cycle. I recommend 3 passes. Pass 1. Secure your definitions and key contrasts. Know exactly what binary is versus Denary. Pass 2. Rehearse worked explanations, system sequences like the ADC we just talked about, and practice your conversions until they are second nature. Pass 3. Adapt to new contexts. Force yourself to justify a choice or change the scenario. Ask yourself, what if this was a robotics factory instead of a retail store? This layered 3-pass structure builds incredibly adaptable knowledge that you can reuse across every single chapter of the computer science syllabus.
And finally, Section 5, the 4-question check. This is the final polish on your masterpiece.
Whenever you are studying binary, Denary, or frankly any computer science topic, I want you to run it through these 4 specific prompts. Question 1. What is it? Define it clearly. Question 2. How does it work? Explain the mechanism. Question 3. Where is it used? Give a real-world context. And question 4. Why is it better or worse than an alternative in that specific situation? If you can answer these 4 prompts out loud, clearly and logically, without stumbling, your topic is exam ready. If you hesitate, or if your answer relies on vague words like stuff or things, you need another revision cycle. Seriously, don't walk into that exam hall until you can smoothly pass this 4-question check for your core topics.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Because the next time you sit down with a blank exam paper, you have to ask yourself, are you just hauling a heavy, useless block of raw data into the exam hall, hoping the examiner will do the heavy lifting for you? Or are you ready to pick up the chisel, apply the Peel framework, nail the context, and reveal the masterpiece hidden inside the binary? The raw material is already in your head. The final shape is entirely up to you. You've got this.